Hi there, this is Miss Townsend and I love math. Welcome to Math with Townsend. So I'm making this video for grade 10 students who are working on their summative questions. This is the solution to question number 5. And here's the question. It says, determine the type of quadrilateral created by the points of intersection of these 4 lines. So obviously what this means is if I were to graph those lines, they intersect at 4 different vertices. And those vertices create some sort of four-sided shape. And the question is, what type of four-sided shape do they make? So before you do any math, you obviously want to make sure that you know what the types of quadrilaterals are and what the properties are that differentiate between them. So again, notebook, use your textbook, or use the internet and figure out what the types of quadrilaterals are that your teacher expects you to know. So I went to one of my favorite websites. It's called mathisfun.com. That's all one word, because math is fun. So here's the types of quadrilaterals. Certainly the most famous type is the parallelogram. And within the family of parallelograms, there are different types. So if something is a parallelogram, it might also be a rectangle, or it could also be a rhombus. And of course, the most special type of parallelogram is one that is both a rectangle and a rhombus, and those are called squares. So maybe it's one of these 4 types of parallelograms, but maybe it isn't. Maybe it's a trapezoid. So you probably studied what a trapezoid is. I mean, obviously, if you didn't study a trapezoid, then don't worry about it because your teacher wouldn't ask you for something that they didn't teach you. But just in case, another type of quadrilateral is a trapezoid, and there is a special classification. One type of trapezoids are called isosceles trapezoids, so maybe it's one of those. Or maybe it's something called a kite. Again, if you didn't study what a kite is, then don't worry about it. But maybe you did, and it's good to just talk in general about quadrilaterals anyway. And if it's none of these, if it's not a parallelogram or a trapezoid or a kite, then it's probably just a quadrilateral. And I'm not saying that just a quadrilateral is a bad thing. All of these are quadrilaterals. It's just some of them don't have any other classifications other than just a four-sided two-dimensional shape. So now that we've talked about the types of quadrilaterals, what sorts of things do we need to study in order to differentiate between them? So once I know that I have a four-sided shape, what do I need to look at? Well, you need to look at things like this. Are opposite sides parallel? Are adjacent sides perpendicular? Are opposite sides the same length? Are all sides the same length? These are the questions you need to be addressing if you're trying to demonstrate what type of quadrilateral you have. And the nice thing about these questions is they kind of fall nicely into 2 big categories. This category is thinking about the slopes. So the slopes of the sides have what sort of properties? Parallel, perpendicular, etc. And these 2 questions have to do with side lengths. So it's a lot to do with finding slopes and looking at those, and finding side length and looking at those. So before we go any further, let's look a little closer at the lines that we're talking about. So line 1, line 2, line 3, and line 4. So I've just rewritten them here. And again, we know that one of the first things we need to look at are the slopes. So we don't need to do anything terribly fancy to talk about slopes, because we can just rearrange equations and tell you what the slope is. For example, line number 2 is already in slope-intercept form. So I can tell you right now that the slope of line 2 is 1. And line 3, I can tell you right now that the slope of line 3 is negative 1 over 2. So I'm giving it to you as a fraction just because I prefer fractions to decimals. So let's look at line number 1 and put it into the format slope-intercept so we can tell you what the slope is. So I'm going to isolate the y term. So negative y equals negative x minus 3. Divide everything by negative 1. So there's line 1, and that gives us a slope equal to 1. And then down here, I'm going to do the same thing with line 4. I'm going to rearrange it. So isolate the y term, and then divide everything by 2. So negative 1 over half x. Negative 12 divided by 2 is negative 6. So all of my lines, I know their slopes. And I mean, obviously, look at line 1 and line 2. They have the same slope. Therefore, they're parallel. Look at line 3 and line 4. They have the same slope. Therefore, they are parallel. So I've already answered the first question. Both sets of opposite sides are parallel. So in other words, not only are these sides parallel, so are these sides parallel. If I only had one set of parallel sides, so if these were parallel, but these weren't, for example, something like this, that's a trapezoid. But that's not what I have. I have both sets of parallel lines are parallel. Sorry, both sets of opposite sides are parallel, and therefore this must be a parallelogram. So if we go back to our list of possible quadrilaterals, we know that we are working within this family. So it's either a parallelogram, a rectangle, a rhombus, or a square. So now that we've addressed this question, let's keep looking at slopes and address this question. Are adjacent sides perpendicular? So the slopes that I have for adjacent sides are 1 and -1/2. So, you know the answer already, but let's show it mathematically to get full marks. So does one slope times the other slope equal -1? Is this true? Well, no. Therefore, adjacent sides are not perpendicular. Ooh, perpendicular. My favorite 13-letter word. Is it 13? Oh, it is too. Yay me. Okay, so adjacent sides are not perpendicular. Therefore, let's go back again. Therefore, I can't have a rectangle and I can't have a square. So I either have a parallelogram or a rhombus. These are the two possibilities left. It's either a parallelogram or a special parallelogram called a rhombus. So now we have to start looking at side lengths. So before I look at side lengths, how do you look at side lengths if all you have are the equations of lines? Well, obviously you can't just look at side lengths. What you need to know where these vertex points are. So I need to know the coordinates of the 4 vertices of this shape. And how do I find them? Well, I have lines, and those lines intersect. So I need to know where those lines intersect. So what I want to do is I want to get a decent picture of this system of equations. So let's, again, sorry for flipping around so much, but here is a system of equations. There's 4 of them. And I want to kind of get a feel for what they look like on a graph, so I know which lines intersect and which lines don't intersect. And I know kind of what it roughly looks like, so I can start to do math a little more intently. So what I've done is I've grabbed, there's a piece of software available, I think it's shareware, called Graphmatica, and it's my favorite graphing tool. And I just told it to graph the line. So there they are. So let's take this. We're just going to make a quick copy of this picture, and let's put it into today's lesson. Technology is good, right? So obviously without technology, you just make a quick sketch. You get a piece of graph paper, and you make a quick sketch, whichever way you like to graph lines. That should be second nature to you now. I mean, you're almost in grade 11. You should have graphed 100 million lines so far. So graphing lines is, not a big deal, right? Right? Good. So now which line is which? Oh dear. So which line is which? So I have a slope of 1 and a y-intercept of 3. So flip, 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 flip. Slope of 1, y-intercept of 3. So that would be line 1. So this I'll label line 1, and therefore this one must be line 2 because it's parallel. This line has a negative slope and a y-intercept of 5. So let's figure out which one that is. So a negative slope and a y-intercept of 5, so that must be line 3. So this one here is line 3, and that makes this line 4. And again, obviously, I can't tell you the coordinates of this point from the graph because it's not a perfect, what we call a lattice point, a point right at the crosshairs. And that means we have to do algebra no matter what. So there's 4 points. Oh, I could probably tell you that one, but we're going to do algebra anyway. And let's label those points. Let's call them A, B, C, and D. So I'll just start here, A, B, C, and D. So we need to find the coordinates of A, B, C, and D. Now, you know, if you're like me, you're probably looking at this beautiful picture and thinking, I probably know that it's not a rhombus. But again, that's not good enough anymore. You can't look at a picture and say it looks like this. Even if your picture is done by some amazing computer-generated software, the point is not, I really care about this shape. Obviously, I don't really care if it's a parallelogram or a rhombus. The point is, do you know how to algebraically verify this shape? And that's what we have to do now. So let's talk about point A. Point A is where line 1 and line 3 intersect. So let's take a look at line 1 and line 3. So again, we're looking for point A, which is where line 1 and line 3 intersect. So this is now systems of equations and solving for the intersection. So I have one line in standard form and I have the other line in slope-intercept form. So I'm going to solve by substitution. So I'm going to take this value of y and I'm going to substitute it into the other equation. So let's do that math. So in other words, I'm going to sub L3 into L1. So here's line 1, x minus y plus 3 equals 0. And you notice I didn't actually write y. I wrote bracket because that's what I'm going to substitute. So and the value of y I'm substituting is this one. So negative 1/2 x plus 5. So there's my substitution. And that leaves me with one equation with one unknown variable. So let's do this math. So I have x plus 1/2 minus 5 plus 3 equals 0. So x plus 1/2, so 3x over 2 equals positive 2. So this was negative 2, and then I added it to the other side. So isolating x, 3x equals 4. Oops. Divide by 3, x equals 4 over 3. So now that I know x, I have to find y. So now I'm going to sub x equals 4 over 3 into one of my equations. Which one do I like better? Let's use equation 3 because it's already in y equals form. So y equals negative 1/2 x plus 5. And we're going to do that substitution. So remember, we take this value of x and we sub it into that bracket. And now we just have to do the algebra and solve for y. So y equals negative 4 over 6 plus 5. Reduce that fraction. Y equals negative 2 over 3 plus common denominator 15 over 3. So y equals positive 13, over 3. Negative 2 plus 15, yeah. So that means here's point A. And point A is at 4 over 3, comma, 13 over 3. And I'm just going to go back to that graph and make sure that this is where I find it. So it's about 1.3 and 4.3. So looking at the graph, if I go over 1 and a bit and go up 4 and a bit, hooray, I have the right point. So this video is almost at its maximum length. So I'm going to stop here. I'm going to find the coordinates of B, C, and D without you. Sorry about that, but you know, time. So you do that too. When this video ends, take out your pen and paper, find the coordinates of B, C, and D, and I'll meet you back at video 2. See you there.